How's everyone doing? Pretty good? All right, so I'm going to kick this off by reading from one of these. Do you remember these? It's a book. All right, so a well-known scientist once gave a public lecture on astronomy. She described how the Earth orbits around the sun, and how the sun, in turn, orbits around the center of a vast collection of stars called our galaxy. At the end of the lecture, a young man at the back of the room got up and said, "Well, actually, what you have told us is rubbish. The world is really a flat plate supported on the back of a giant tortoise." The scientist gave a pause and then a kind of superior smile before replying. "What is the tortoise standing on?" "You're very clever, young lady, very clever," said the young man. "But it's turtles all the way down." So you might think that the picture of our universe, where it's some sort of like recursive turtles with the world on top of it, is pretty absurd. But you also might ask yourself, what do you really know about the universe, and how do you know it, and why do you think that you're so right about it, and what the heck does this have to do with JavaScript? My name is Ashley Williams. You might know me as AG Dubs on Twitter, and I work for this little company called NPM that you might have heard of. Yes, it is a company. And my job there basically is to explain how NPM works to anybody who wants to know. And kind of as a side benefit, I also get to help NPM grow into something that's a little bit easier to explain. In addition, I write a lot of bad code all the time. This is code from the presentation that I'm giving right now. And so if you'd like to remember who I am and that I work at NPM, you can NPM install AG Dubs, and it will tell you that. But if you're interested in the slides for this talk, you can also NPM install a brief history, and you'll get them. Since this talk is about modularity, I figured I'd be cute and put it as a package on the NPM registry, but I also made a bit.ly link, because that's also just way easier. And sometimes modularity is not the answer, but more on that later. So I like to kick off my talks by saying that I like to think about thinking. And I especially like to think about the type of thinking that happens when people write code. And my sound is all sorts of messed up. All right, we'll deal with it. All right. That is breaking in and out, no? All right, we'll just power through till someone deals with it. So I like to think about the type of thinking that happens when people write code. And it might be because I got really into philosophy and neuroscience in college. But I also really just like asking the question, why? Because it isn't enough to just have ideas. You should also know why you have the ideas that you have. And so I've been giving this talk for around the last year, not this talk, but a previous talk, and that talk kind of has a punchline that says, "Teaching is nature's way of letting you know how sloppy your thinking is." And this was extremely poignant because I've also been spending the last year teaching a lot of amazing people how to do Node and NPM. And that's a little initiative that I'm doing to improve diversity in Node, so you should check that out, shameless plug. But when you're a teacher, you get a lot of really difficult to answer questions, like this one. But this isn't the one we'll talk about today. Today I want to talk about how do you decide what goes in a module. And so, as any good scientist would, I went to Twitter to get some data. And so I asked people, I said, what is your primary motivation for writing/using modular code? And a lot of people responded. A lot of people had some serious opinions about this. And one of them was testing. They're like, if I modularize my code, we are way more responsible and like way more motivated to test well. Other people, Bradley Ferris, for example, said that so he didn't have to write future things that he already had done in the past. By the way, if you are interested in modules, and you should be, he is who is working to get ES6 modules compatible with Node. So that's a big thing that everyone should be paying attention to, and props to him for doing that. Now, additionally, of course, it was Twitter, so there were some jokes, some not great jokes. But then additionally, some people talked about, say, reuse and separation of concern. And I pressed them. I said, OK, I get that, I buy that, but how do you decide which concerns to separate? And people really started struggling when I pushed back on that. They were like, I don't know. I should think about that. Some people talked about having a mental model and abstraction boundaries. And I was like, OK, so what should go in the mental model? Where do you draw the boundaries for the abstractions? This person suggested that they threw darts. Not necessarily the best answer. Now, even the person who wrote the book that I learned JavaScript from chimed in, which is why Twitter is amazing, eloquent JavaScript. He jumped in, and even he was like, you know what? He gave some good answers, but he's like, at the end, it gets pretty cloudy. I think in the end, the best answer I got was from Julia Evans. And it's like, why do you write modular code? Well, people got mad when I put it all in one file. That's pretty honest. I think this is probably one of the best things to say. Because in the end, it seems like everybody could say what the good effects of modularity were, but when I was like, how to module, no one really had a great answer. And so I did something that, if you knew me, would be kind of classic, but if you don't, might seem a little bit strange, is I was like, whoa, I think the concept of modularity is kind of like the concept of time. And it's like, wait, okay, let me explain exactly how I jumped to that conclusion. So the way I jumped to this conclusion was the idea that, like time, you could be like, well, what's time? And someone's like, points at their watch. And you're like, okay. Or like they points at the fact that change happens in the world. And then with modularity, I could be like, well, look at this store. And you'd be like, yeah, that store is probably doing too many things. That's a real store by Penn Station in New York City, where I live, real place. So we can kind of say, yeah, that's too many things, but if we asked you to defend like what your intuitionistic sense of modularity was from like first principles, similar to me being like, no, 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 what really is time, you'd probably go like this. Don't really know. And so I decided, hey, I got this book here. Why don't I do like a little Stephen Hawking on this idea of modularity? Because I'm super into physics, and I also work at NPM, and so this seems like the perfect thing to do. And so in order to start, I had to get a picture of the universe. And that was kind of simple for me, in fact, to think about the universe from a modular standpoint, because at least in JavaScript, the universe is kind of NPM. NPM has at least quite a bit of the JavaScript that's out there, and it's certainly the vast majority of the modularized JavaScript. Now, I'd really like to play this right now, but I'm worried about time. But the reason that so many people create these amazing visuals of NPM is that it kind of looks like a universe when you visualize it out. And so this is a beautiful visualization that has been redone by this programmer named Ivanka, and he uses a graph algorithm for this, and it's super great. I'll show you just a little bit briefly. But he kind of scopes in here. I think this is great. He has each dot as a package, and then there's like the Lodash galaxy. It's pretty sweet. Anyways, so as of yesterday, the NPM registry had 336,000 total packages, and just for that day, had 224 million downloads. That's a lot of modularity happening, all right? And if you check out module accounts, if you're not familiar with it, this is something that indexes all the packages across all of the package ecosystems. NPM is by far the one with the most packages, and it doesn't even start until 2012. NPM is the largest module repository in the world. But I kind of want to know why. Like, why so many modules? There's too many modules. And so this wouldn't be a good computer science talk if I didn't give us some Dijkstra, right? So let's get that out of the way. So in his really awesome paper called On the Cruelty of Really Teaching Computer Science, he says this: the programmer is in the unique position they have to be able to think in terms of conceptual hierarchies that are much deeper than a single mind ever needed to face before. The automatic computer confronts us with a radically new intellectual challenge that has no precedent in our history. Now, I'm not like a huge fan of computer science exceptionalism, but I do think that he has a point here about the levels of abstraction that we need to traverse every day to do our job in computers. And what I want to try and suggest is that modularity is a way of addressing this challenge. It may be a way of coping with it, or it might be a way of flourishing in it. And that's kind of what I'm hoping to tease out today. So the first thing we should ask ourselves is, what is modularity? And as a good academic, I went to Wikipedia to get a definition. And so Wikipedia says, modular programming is a software design technique that emphasizes separating the functionality of a program into independent, interchangeable modules, such that each contains everything necessary to execute only one aspect of the desired functionality. Now, I want to focus on that one aspect. Like, how do you define where the boundaries of that one aspect are, and which aspect? You might notice that I stubbornly ask the same questions all the time. That will continue. And this kind of brings us to this small modules philosophy. How many people have heard of the small modules philosophy? Some people. How many people could intuit what it potentially means? How many people assume I'm going to challenge those intuitions? Probably, right? Yeah, there we go. This person named Sindrasaurus, he's a very epic publisher of packages at NPM. And he says this. He says, it's all about containing complexity. By making small, focused modules, you can easily build large, complex systems without having to know every single detail of how everything works. Our short-term memory is finite. So okay, I think this kind of makes sense. It's like we only have like tiny brains, and if we're trying to deal with this massive challenge that Dijkstra just explained, it might make sense to try and just break things down into smaller pieces. It doesn't even matter what pieces, we just need to make them smaller. And you might be thinking this, but I certainly thought it was just like, how small is too small? And I'm not the first person to ask this question, nor will I be the last. In fact, somebody asked him on his AMA on GitHub, lots of people don't get the benefits of one-line modules. What would you say to those who tend to critique a lot of node modules that have just one line in them? And probably before I even got to the end of reading that, I imagine that some of you thought of this. Now, warning, I have a lot of feels about LeftPad, and while it might have been devastating to the community, to Azure, to the people whose builds broke for only 1 hour, I'll remind you, LeftPad jokes are super not funny to people at NPM. So if you see me later, or if you see anybody at NPM later, or if you go on Twitter, don't make that LeftPad joke. Seriously, everyone at NPM will thank you. So anyways, LeftPad. For people who might not know, LeftPad was a situation where somebody who published packages on NPM got mad at NPM for reasons that at this point do not matter, and decided to take them all down. When he took said packages down, the internet went on fire. The internet got super mad. The media was all over this. It was ridiculous. We were told that we broke the internet. And what you'll notice here is that people really focused on how many lines of code it was. Here we see unpublished 17 lines of code, broke the internet. Oh my God, 11. They couldn't get the number right, which was fascinating to me because they were so focused on the lines of code. And so people during the situation, they were mad at NPM, they were mad at Azure, but the thing that I thought was the most interesting was the people who got infuriated with anyone who had depended on the LeftPad package. Here, Aaron Hammer, who is the writer of a very modular framework called Happy, says, the fact that LeftPad is a module and the other people required it is the real breakdown in common sense. Now, this isn't even the worst one. I mean, these two aren't. But here, this person wrote something that was very thought-piecey, that was like, have we forgotten how to program? Have we forgotten how to program? What a ridiculous thing to say. Have we forgotten how to program? All right, this is the code. This is the code I found. It was 11 lines. All right, just because I didn't want to write this a bunch of times in my app, it means I forgot how to program? All right, did we forget to program when we stopped writing C? When we stopped writing assembly? When we stopped doing electrical engineering? I wrote electrical engineering there because I didn't know what to put, because I don't do electrical engineering, but I am still a programmer. And so I mostly bring this up to say this is a no true programmer argument, which is this no true Scotsman logical fallacy. And I have no time for it. This is absolutely absurd. We're going to be looking into modularity and critiquing ideas about it, but at no point are you no longer a programmer if you have the wrong answer, of which there is not one. If you're tarrying with this topic at all, you're a programmer, and I'm sick of these arguments. So to go back to these ideas of modularity, I think Substack says it best, and it's too bad that he couldn't be here today. But he said, when applications are done well, they are really just the application-specific brackish residue that can't be so easily abstracted away. All the nice reusable components sublimate away onto GitHub and NPM, where everyone can collaborate to advance the commons. And I like this because I'm like kind of like a secret, it's a not so secret communist. So I'm like, ooh, communism all the way down. I'm into it. Anyways, but the left pad situation really brings this idea to a point, which is that the commons are hard. The commons are hard. But if you look at the NPM data, the commons are also very good. These are the weekly rolling downloads of NPM packages. They are not slowing down, they are speeding up. And so you kind of have to ask yourself, for something so complex and messy that deals with so many people, all these unpublishing and stuff, which is no longer allowed, by the way, how do we do it? And so there's this person who's actually a pediatrician, but he wrote one of, I think, the most entertaining and like fascinating books on systems called Systematics. It says how systems work, and especially how they fail. And he says this, he says, a complex system that works is invariably found to have evolved from a simple system that worked. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a simple system. So what is that simple system? So let's talk about what is simplicity. All right? And that might seem like a goofy question, right? Oh, what is simplicity? It's kind of like, have you ever looked at your hand? But simplicity is pretty hard to define. And my favorite definition comes from a talk by this man named Rich Hickey, who writes the Clojure programming language, in a talk called Simple Made Easy. And here he defines the word simple as coming from the terms sim and plex, where sim stands for one and plex means a fold or a braid. Now, I love this because when we're talking about words and theories and concepts, they often can be very difficult, but this is a very, very physical definition. I love the idea of seeing something that's simple is like folded one time, and something that's complex has tons of folds. A crumpled up piece of paper is complex. Now, how do we take this and apply it, though, to these kind of mushier other topics when we're not just talking about a physical paper? Well, that's when I kind of ask myself, well, what is information? And so there's this guy named Cesar Hidalgo. He's a physicist slash economist, which is fascinating. And he wrote this book called Why Information Grows, which I'm super into. So instead of talking about left pad, we can talk about why order in the universe deteriorates even though it grows on Earth. Much more interesting topic. But that's what the book is about. But in the book, there's a fascinating definition of information, where he says, information is not a thing. Rather, it is the arrangement of physical things. It is physical order, like what distinguishes different shuffles of a deck of cards, or potentially a tree in a node modules directory. What is surprising to most people, however, is that information is meaningless. It's simply the structure. All right? It's not what the modules contain. It has to do with how we put them together. And that brings us to the trouble with modularity. Now, when I'd asked about modularity, everyone was like, yeah, modularity, I like it, and I definitely do it. But it turns out it's kind of a huge problem. And here, Nolan Lawson, who does a bunch of awesome work, says, the more I modularize my code, the bigger it gets. And this is true. He follows up by quoting Sam Saccone in this amazing blog post we're about to talk about, where he says, over 400 milliseconds is being spent simply walking the Browserify tree. How many people here use Browserify? How many people like how long it takes? That's cool. I'm not here to hate on anything. I just am here to ask a lot of questions. All right, so he wrote this blog post called The Cost of Small Modules, and I was immediately drawn to it. And I was immediately drawn to it to draw it, and it really had nothing to do with my interest in modularity. It was because he tweeted this, which I thought was fascinating. He said, why one horse-sized JavaScript duck is faster than 100 duck-sized JavaScript horses. I had to draw it. Clearly, this is what needed to happen. But this is a really interesting thing, and this is what he deals with in it. What he does is he looks like how many modules are in a typical web application. And so he had a couple of examples here. We go from 91 modules in require bin all the way up to 1,060 modules in apple.com. And he says, ignoring the size of these modules, all right, how does how we package them affect the time? And how does that time change as we increase the number of modules? And so here, thinking that we already thought, oh, breaking down things makes so many things better. If you look at the top three of each of these top three will maintain the modularity that you have designed during development time, where the bottom two will not. And what you can see is that clearly both load time, but particularly runtime, is significantly worse when we maintain the modularity on the browser side. All right? It's not the size of the modules. It's the sheer number of them. All right? And so Rich Harris had followed up to Singer's blog post on the small modules philosophy. And he says this. He says, yes, small modules are easier to write. Yes, they're easier to test. These are all the things we heard on Twitter. Yes, it's easier to adhere to Semver. These are all the things that make your life easier as a library author. As we've seen, they come at the cost for others. All right? So to a certain extent, you could say that the small modules philosophy benefits the library writers. They love it. They'll break everything down into extremely small modules. Their modules will depend on lots of other small modules. Everything will be well tested and reliable. But it disadvantages the application writers because they do not have control over those transitive dependencies. And then, as a result, fundamentally, it harms our end users, and it makes their runtime slower. All right, so how did we end up here? How did this happen? All right, and this is when I like to pull out my philosopher friends. This is Thomas Kuhn. He's an amazing philosopher of scientists. Yes, I consider him a friend. No, we have not met. He says this in his book, The Structure of Scientific Revolutions, which if you have the tolerance for books, it's a good one. He says, scientists work from models acquired through education and through subsequent exposure to the literature, often without quite knowing or needing to know what these characteristics have given these models the status of community paradigms. So there's a good chance that a lot of us are practicing this idea of modularity without ever having questioned it. All right? And this is a problem because our lack of questioning it is not just inconvenience. It's not me waiting in Oakland for a BART train. All right? These are real problems. And I think SiegeBot puts this best. This is Sijo Silverio. She's the CTO at NPM now. She's super awesome. She's who introduced me to John Gall. But here's the thing that we never think about with a small module. She says, your monolith is complex. A split system is more complex. So no. Am I saying that the solution is probably worse than the problem? I don't know. Am I? All right. And so I'm not saying that we should throw away the idea of modularity entirely, but I do want to point out, as Rich Hickey points out here, is that most of the big problems in software are problems of misconception. So it's not that modularity is bad, it's that we have not conceived of it quite the way we potentially should. So what I want to talk about is the idea that software development is fundamentally change management. When we are developing, when we are writing programs, we are just constantly writing and preparing for change. So in Stephen Hawking's book, A Brief History of Time, he makes this interesting side comment where he says, it's an interesting reflection on the general climate of thought before the 20th century that no one had suggested that the universe was expanding or contracting. And I think oftentimes when we think about computer science and when we apply them to our programs, we don't think about the fact that they are going to change. The change is not the primary motivator for what we are doing. Now, when I did this search for why module, how to module, it turns out, unusually, that when I did this on Google Scholar, there was one paper that was exactly what I needed. And it was this person named Dave Parnas. How many people here know Dave Parnas? Know him now. This is amazing. All right, he wrote a paper so aptly titled, on the criteria to be used in decomposing systems into modules. All right, and he says this. He says, start with a list of difficult design decisions or design decisions which are likely to change. Each module is then designed to hide such a decision from the others. The goal of modularity is not to make things easier. It's to hide the things that are hard. Again, when I ask, why do you module? Everyone moduled because it was testing, but everyone moduled because they could think about it easier. But what we should be doing is we should be taking the tricky parts and making sure that they go really far away from the other parts so that they don't mess things up when when everything changes. All right? Now, here's a fascinating thing. When I was also doing those looks for papers, I found a biology paper where it was like the evolutionary origins of modularity. And I was like, all right, I'm going to get really deep on this one. But it turns out that it actually made a lot of sense, and it totally confirmed what Parnas was saying. All right, he said, here we demonstrate that the ubiquitous direct selection pressure to reduce the cost of connections. I don't even need to go through the quote. The idea was that when we are trying to reduce the cost of connections, which is exactly taking the hard parts and getting them the heck away from everything else, all right, it evolved directly into an extremely efficient modular system. Now, I'm not going to play the whole video, but you can see that things start as a tangle, and if they select for just performance, they remain a tangle. And they are not very modular, and they are not very performant. But as you move on later, performance is spiked, and you can see that they're completely untangled. And that's when they took the cost of connecting into consideration. All right, so now, like, good, we talked all about this, but like, how to computer? I still don't know. Yeah, it's hard, all right? None of us were born knowing how to write software, yet, I guess. I mean, who knows? And even Cinder says, like, keep in mind, I failed doing the right thing hundreds of times before realizing that making a separate module would be a better thing, all right? But all is not lost. Yo, dogs know calculus. Did you know this? Corgis. All right? Dogs know calculus. The person wrote a paper, and basically what it showed was that corgis were able to do extremely advanced calculus to calculate the optimum path to a ball based on the texture of the difference of the land they had to run on. And they did all of this in their head. It's like super awesome. Look how accurate they were. That's the optimum line, and that's the data. Corgis are really good at calculus. That's pretty awesome, right? Now, corgis don't know calculus, but what we're saying here is that corgis have developed an intuition. And so while I've spent a lot of time saying that maybe intuitions aren't the most awesome thing here, you still should very much trust your intuitions, because your experience with failure is probably your number one, like, selling point as you're a programmer. Your experience with failure. That's where your value comes from. All right? And so we're kind of made of math. Corgis are made of star stuff, and so are we. And this is a corgi, and I love this corgi very much. But perhaps even with a small talk of corgis, maybe you're a cat person, you still feel despair. All right, and when we despair, we think of Sartre. And so this is a quote from Jean-Paul Sartre's ANSI Programming in C. Every line of code is written without reason, maintained out of weakness, and deleted by chance. So yeah, that's actually not Sartre. That's this ridiculous dude Teff here, who's an extremely good friend of mine. He writes a blog called Programming is Terrible, and he's probably right. But he wrote this amazing blog post that said, write code that is easy to delete, not easy to extend. Instead of building reusable software, which is like what everyone thinks modularity is about, stop building reusable software. We should try to build disposable software. I don't need to tell you that deleting code is more fun than writing it. Hands if you like deleting code. There we go. All right, so he had a couple of tips, and I'll leave you with them, is repeat yourself to avoid creating dependencies, but don't repeat yourself to manage them. Layer your code. Build simple-to-use things out of the clumsy-to-use parts. Split your code. Isolate the hard-to-write and the likely-to-change, both from the rest of the code and from each other. All right? But mostly, don't try to do all of these things at the same time, and maybe don't write so much code in the first place. All right? And so I'm going to end with something crazy, because as I've told you, I like to think about thinking. And I like to think about weird physics stuff. So I'm going to say, what is space-time, right? Like, space-time refers to whatever external reality underlies our collective experiences of the space between things and the time between events. Like, okay, cool, but like, why not just time? And why not just space? Like, why do we have to add this extra concept, space-time? Seems kind of unnecessarily complicated, and I would agree, except for this. So it turns out that if you have two observers moving at relative speeds to each other, they can't agree on how much time passes, how much space was covered, and they even can't agree on the chronological order of events. None of those are certain in physics, all right? Yet neither of them are measuring wrong. They're exactly accurate. So please remember this the next time someone tries to tell you that their way is better, that React is definitely the way to go, all right? We don't even know like what order events are happening in the world, all right? We can't be certain of these things, all right? What is time is a tough question, and it's not even the full question. And what is modularity is also a tough question, and it's not the full question. So I'll leave you with this. This is from Julia Evans, the person who gets yelled at when she puts it all in the same file. She was joking, by the way. She's a brilliant programmer. But she says this. She says, the more programming I do, the more I run into where I don't know, Google doesn't know, my colleagues don't know, and we got to do it anyway. And when this happens, I think, right, this is why they pay a human with a brain who can investigate and learn. Again, you can find these slides at a brief history, and look out for the turtles. Thanks.